Hi everybody, my name is Charlie Kepler. I'm an applications engineer and lead pilot here at Headwall Photonics, and today we're going to go through the steps for setting up a mission and doing a flight with the DJI Matrice 350 and the Headwall Nano HP sensor with LiDAR. This sensor has a 12mm lens, got it all powered up and connected, and now we're going to go ahead and get ready with our acquisition. So the first thing that I'm going to do is I'm going to make sure once my Ethernet is plugged into the computer, I'm going to launch HS Insight by going to a web browser. So in this case, I'm going to go to Google Chrome, open it up, and go to 10.0.65.50, which is the IP of the VNear sensor. Once I load that, I'm going to see this connected symbol at the top of the screen, and I see I have LiDAR and GPS are both green check marks, which means that I have LiDAR and GPS connections. First thing I'm going to do then is go to the sensor settings and then open up the live view. I see this spectral plot on the right here, which is telling me I'm maxing out at around 42%. So I want to adjust my exposure until this screen is about 90% of saturation. I'm going to make sure I'm selected on a good pixel here. I'm kind of in a darker region here, so I'm going to click on this spot. Make sure that's kind of a more uniform area. And then, yeah, I'm looking at shadow right now. So I'm gonna have my assistant Carson do a little tip of the drone such that I'm illuminating this white reference. There we go. And now I see, oh, I'm saturated. I notice my drive usage says 33%, so that's okay. I like to clear it off if it's higher than, say, 60 to 70%. You'll notice we have a nice canopy above us. That's obviously not required, but it's nice to be in the shade while the sensor is still in the sun. So whether you have it set up on a cart or a table or something like that, you have the sensor in the sun looking at the white reference or the white tile, and then we're in the shade so that we're not getting overheated or sunburnt or anything like that. So now I can adjust my exposure down. We'll try, instead of 4.5, I'll try 2. And I'm still saturating, so I'm going to go a little bit lower, 1. And that looks a little bit better. I'm maybe a little bit too low, 73%. So maybe I'll go a little bit higher, 1.4. And now is a little too high, so 1.2. And now if I hover over, I'm seeing 90, 81, 90, yeah, so that's pretty good, somewhere around 85 to 90% saturation. This is a shadow from the cable from the Ethernet right there, so I'm outside of that. So my exposure I'm happy with at 1.2. My frame period needs to be greater than or equal to the exposure with a minimum of 5 milliseconds. I have normal, low, or high. If it's a cloudy day, I'll do high. If it's a bright sunny day like it is today, I could potentially go to low gain, so let's try that. That drops the signal down, and so in this case then I could increase my exposure to a higher value. Today I'm just going to operate in the traditional normal gain, so I'm going to go back to what I had before of 1.2. I'm going to make sure I have the correct lens selected, so this is the 12mm, and then today my altitude is going to be at 60 meters. Just going to refresh to make sure that that lens change was taken into effect. So I have exposure 1.2, frame period 5, you can put that down. Thank you.
Those numbers?
Exposure is 1.2 and frame period is 5 milliseconds. We've developed a flight checklist that we use internally. We're happy to share that, although it's more designed for our production testing, but you can take that and adjust it yourself, or even better, design your own checklist for your own operations. So that's what he's doing right now, is writing down our values.
Flight speed recommended?
So next thing I do is I put in my altitude, which I said is going to be 60 meters, and then based on those parameters, it tells me a suggested speed. That suggested speed is telling me 5.9 meters per second. So whatever that suggested speed is, we take that value and subtract half a meter per second. So instead of 5.9, we're going to fly at 5.4. And so 5.4 is what you can write down. And so I'm happy with those values. I'm going to now move down to the GPS tab. And I'm getting latitude, longitude, altitude, and then roll, pitch, and yaw are all 0, which is what I expect. This system has not taken off and done its IMU initialization yet, so it doesn't have a good lock for roll, pitch, and yaw. So as long as I have lat long and altitude, that's what I'm looking for. And then I'm going to go upload polygon. I'm going to navigate on this computer to where a previously generated polygon lives. Select it, open, and then it's going to be shown in this region down here. There's a little X where I am. There's a section here where I'm going to place my calibration tarp. And then here's the main area where we're going to be collecting. Then we move down to data capture, where I will put the lens cap on. Carson, if you could do that for me, please. I'm going to, while he's doing that, I'm going to give it a folder prefix and, if desired, a folder suffix. Usually I'm just going to do a prefix today. So I'm going to call it NHP110, which is the serial number. Test.
Is on.
And then one thing you have to make sure you do when you're making any changes in the HS Insight software is after you change a value or enter text, you have to enter, and you'll see this little check mark show up. Once you see the check mark show up, that means that the information has been written to the sensor. So I have my name, I have my lens cap on, and now I'm going to say collect dark reference. Once I click that, it's going to change, it's going to gray out and go to saying collecting dark reference. It's going to be really quick because it's only going to be 5 milliseconds times 100 frames, so half a second about. So I say collect dark reference. Is the lens cap on? Yes, it is. I can say yes, proceed. It is collecting dark reference. And then once it's finished, it pops back. So now I'm going to remove my lens cap, put it on the side, and now I'm ready to start my mission. Before I start, I'm going to go to my flight plan and make sure I upload that. And then once I upload my flight plan, I'll start the collection, and then we're ready to go and take off. So I'm going to go into the Headwall GCS program powered by UGCS. I have pre-built a flight plan here. You can see where the drone is located. Here's my first waypoint. So I'm going to fly across here, which is where my tarp is located, which we put out in the scene over there. So I'm going to fly over the tarp, out to the corner of the parking lot. I'm going to do a lawnmower pattern and across this survey area. It looks like 4 flight lines, and then I'm going to fly back around and back over the tarp to the beginning point. I have set my capture area to a GSD of 2.93, which is 60 meters. And once I'm good with that, I'm going to select my drone, which is shown up here as this M350 RTK, and I say upload to drone. Although the last thing I need to do is change my speed to 5.4. It's gonna do its thing, upload, and now I can actually upload it. I have the option of from start, from selected point, or from last RTH position, so I'm gonna say from start. It's uploading, it shows up on the remote control and says successfully uploaded. And I can look at my telemetry in this pane here. And then once I put the UAV over to the takeoff point, I'm going to take off, do my IMU initialization, which I'll talk about when I'm in the air. And then once I'm ready to start my mission, I'll click this auto mode and it'll go into flying the mission. So I have uploaded my mission. The last thing I'm going to do is click start on my collection. Start. Is the lens cap off? Yes, it is. I can say yes, proceed. I am collecting GPS data, I'm collecting LiDAR data, as long as this white LiDAR cable is plugged in. But I'm not collecting hyperspectral until I enter that polygon. So at this point, I'm going to close out of the browser window, disconnect from there, and then Carson will put it out at the takeoff location for me. He's doing a quick check on the propellers and the arm locks and the legs, making sure that everything is secured, connected, locked, and ready to go. It is our policy that the pilot is the closest person to the UAV when taking off, and everybody is at least about 10 feet or so back. So I am ready to go. So I'm going to power the UAV on by both sticks into the middle, and then I'm going to left stick straight up to take off to a safe altitude, and then I'm going to do my IMU initialization flight, which is a procedure of flying as fast as I can in one direction for about 3 to 4 seconds, coming to an abrupt stop by doing this right stick back until it comes to a complete stop, rotating by 180 degrees, and then doing the same procedure back to the start point. And then at that point, I'll be ready to go to the computer and click auto mode. 49% and 1:24 p.m. We call out our battery percentage and time, or we have our assistant writing those down so that we can keep track of that in our flight log. And so he's doing a paper copy, and then we will then transcribe that into a spreadsheet that we keep on our server. All right, so I am taking off. And then up. I go up to my flight altitude of 60 meters, approximately. Doesn't need to be perfect. And there I'm at 59.3, and I'm going to fly away from my polygon so I don't collect extra data right now. So I'm going to go forward, 1 Mississippi, 2 Mississippi, 3 Mississippi, and then full stick back until I stop. Come to a complete stop, rotate 180, and then do the same procedure back to the start. 1 Mississippi, 2 Mississippi, 3 Mississippi, stop. I'm going to fly such that I'm a little bit behind my first waypoint and facing towards it, and at approximately the right altitude. Go back to my flight program. And I can see my drone is a little bit behind that first waypoint and facing towards it based on that little area, little arrow, I mean. And now I'm going to say auto mode. Are you sure you want to run command auto mode? Yes. And now vehicle switched to auto mode, and it is flying autonomously. I am now making sure that it is doing what I expect, but I'm basically hands off unless I need to take over and intervene. So now we're going to walk with it so that we can maintain line of sight throughout the whole mission. And so we're going to kind of follow it to the front parking lot while it does its thing. The procedure is slightly different if you're using a DJI M300. From there, you would upload the mission and start it from the controller. But for the M350, you have to start it from the computer. It is programmed to have a low battery of 20% and a critically low of 10%. So around 20%, it'll start taking over and returning home. And at 10%, it'll make sure it has landed by that point. Yeah, I think we're good from this position here. And I can see I have loaded in an elevation model of this area into the Headwall GCS program. And so you can see it just went up and over the building here. So it's kind of following the terrain. It's executing its first turn. And then it's going to come back down. So it's flying over the building, and then in a little bit it should start working its way down a little bit. And now we're basically just going to wait while it completes the flight. Probably good to wait in the shade. And just keep a monitor on the battery. I'm at 37%. I will want to try and land by about 20%, which I think I'll have enough battery life here. Okay, and it's going to execute its turn and do its last flight path, and then it's going to head back to the mission start. So I'm going to let it finish the mission, and then once I get the confirmation that the mission has completed, I'll do the IMU procedure at the end as well, so the down and back, which is beneficial for the post-processing with the PPK GPS data. It's beneficial for it to do the same procedure at the beginning as at the end because it does some forward and reverse smoothing, and so we want to do that procedure at the end as well, assuming you have sufficient battery life. If you don't, obviously, then that is when you would just go and land and not worry about it, but the better practice, if you can, is to do that down and back at the end as well. And it's going to get back to that first waypoint, and it's going to stop and hover. and then I will watch the screen. It says mission completed, 27%. I still have control. I have control now, so I'm going to do my down and back bit. 1 Mississippi, 2 Mississippi, 3 Mississippi, stop. Turn around. 1 Mississippi, 2 Mississippi, 3 Mississippi, stop. And at this point now I can bring it in for a landing. We have this nice takeoff pad. I don't usually worry too much about landing on it, especially if there's wind and stuff. But it is nice to have something like that for taking off and landing to keep dust down and things like that. And then left stick straight down to land until the propellers turn off. And now we will plug back in the Ethernet cable to the port 0. We're going to go back to the HS Insight software, so I'm going to launch the browser again. Go to 10.06550. And again, connected, and go to the data capture tab and say stop. My battery level is 22% and it is 131, so land at 130. It takes 60 seconds for it to stop the capture, which feels like a long time, but it really is just 1 minute, so you just have to be patient, and then it will let you know when it has concluded. Once we have stopped the capture, you can hot swap the batteries and do another flight. If you're done for the day, you can go and start downloading the data, which I'll quickly show you how to where we download the data. Or if you have a rotary stage, you can take the system off, bring it over to the rotary stage, and then you can do a ground-based scan of where you are. And so we'll go into doing that next. But in the meantime, we're going to launch the batch processing tool. We get this command line looking window here, which will show us any errors if we see any. And we're going to go to the flight path tab, and we're going to do FTP downloads folders and then process flight. I'm going to make sure that we have capture has been stopped in the HS Insight, so I say OK. And then to download the data, we either can download through HS Insight via the copy to USB button, where we plug in a USB to the front of the sensor and copy the data to the USB. It is our recommendation that is a little bit more efficient and faster to do it via the batch process tool. So we're going to go into here, and then we enter our device IP 10.06550, username HPI, and password. The username and password should be listed on a sticker on your device, and so the password should be capital H, Headwall, capital, or no, lowercase n, capital HP, and then the serial number, which is 110. So Headwall, NHP 110. And I say log in. And we can now see all the directories on this device. And I can select it, whichever ones I want. I'm going to tell it where I want it to download to. So I'm going to browse to my C Nano images directory, select folder, and now I'm going to download this to my C Nano images directory. I'm not going to download it right now because that'll take a little while. The other thing that you will want to do is to download your GPS data. So I'm going to move the Ethernet cable from the port 0 to the GPS port, and then go to the IP of in a web browser again of 10.065.100 this time. And the serial number of the GPS board, which is showed in the upper right corner here, to the 6210C number. If I click on that, I can copy it, and that is the password. So username is admin, password is that we just copied. Okay. I'm going to go to data logging, internal 2024-08, which is August of 2024, and then today is the 14th, default, and then here are all the files that we have collected today in 3-minute increments since it has been powered on. So I'm going to say select all, and then download selected files. Be careful because download and delete are right next to each other. It does pop up with an additional window. If I say download selected files, it says download selected files 30, and I say okay. It would do the same thing for the delete, but say delete 30 files, which we don't want to do. If you do that, it's unrecoverable, and you can use the real-time solution, but not the post-process solution. Again, I'm not going to download these all actually right now because it'll take a little while. So instead, I'm going to power the system down. So press and hold to turn off the UAV. We turn the UAV off before we turn off the remote control in case there is some sort of incident. I'd rather have the controller on while the UAV is on so that in an emergency I can take over and have control, whereas if it was the opposite, there's nothing you can do if the controller's off. So the drone has been turned off. Turn off the controller. And now I'm going to move it over from the UAV to the rotary stage. So first thing I'm going to do is disconnect the Ethernet cable. Put it off to the side. I'm going to unscrew the GPS connector. It should just be hand tight. And unplug the power cable down here. And now I can take the sensor from the UAV and install it onto the rotary stage. So I'm going to open this latch. And now the sensor is loose in that mount, and there's this little button right here. If I press, it will allow the sensor to drop out. So I'm going to make sure I have a hold of it from the bottom, hit the button, and then it'll slide out. We're going to keep this same mount, and we're going to slide it onto the rotary stage here. It slides in, closes, and latches. Tighten it down. And then we need to disconnect the power and plug in the power from the rotary stage battery. We already have the rotary stage powered on through this connection here. So the battery we have in here is powering both the rotary stage and the sensor. We hear the sensor turn on. We're going to disconnect the LiDAR because we don't want any LiDAR data from the scan data. And then we're going to plug in to port 0 with the Ethernet cable. So now we have the Ethernet cable plugged into the computer, and then we're going to plug in the USB for the rotary stage into the computer as well. One thing we did ahead of this was configure the configuration file to be COM3, which is what this guy is calling out. We found that out by looking in our device manager and seeing when we plugged it in which COM port was called out. It's going to be different from computer to computer, or potentially even from port to port. And then we changed that in the in the JSON file that calls that out. Once that is set, now we are all connected. So one thing that Carson was just pointing out is that if the system is not at the 0 location when it is powered on, it's going to do a homing thing. So either we could power it all down, bring it back to 0 and turn it on, or we can just let it do its home while we do some cable management. So we'll let it do the homing right now, and we can launch the HyperSpec 3 program with this NHP rotary icon that I have here. And the first thing I notice is it says motion control device is ready. We have our HyperSpec 3 window. We're going to go and open our live video, and we're going to take our lens cap off. And now we're going to get a spectrum of our scene here, kind of similar to the HS Insight window, except this is it displays the raw digital counts number instead of a percentage. And so we want to set it at approximately 80 to 90% of saturation, which is 4,096. We'll set it to 3,500-ish counts. So I want to have the system looking at our white tile here. So we want the tile to be facing more or less as best we can towards the sun. And now we're going to point the sensor such that it is kind of looking at that tile, which it looks like I need to adjust it a little bit. So I'm going to open my motion control here, and I'm at position 0, and I think I need to go a little bit to the left. So I'm going to go to position, we'll say -10. And it moved a little bit, and I think we went a little bit too far. So let me go back to -5. Oh, and I saw it pop up for a second here. So let's go to -7. Now, if I see here, this is bright. That's where I'm looking at the tile. And so if I hover over here, I said I want to be about 35 to 3,800 counts, and I'm at 3762. So I'm pretty happy there. Again, I want to make sure I'm clicked on kind of a uniform area here. So I'm going to say I'm happy with the value that I chose, which is an exposure of 4.496 and frame period of 5.064. Again, I can set the frame period as high as 5, so I'll start with that. And it may adjust it slightly if it needs a little bit of a readout time, but it looks like it did not. Next thing I'm going to do is I'm going to go to the FOV calculator, and it's going to tell me a angular scan rate. And so I want to set my scan rate to 2.9171 degrees, or the closest that I can to that. So 2.92, we'll say. I'm done with my live video. I'm going to go to capture, give it a folder prefix, so NHP110 Rotary test or something like that. Frames per cube, we recommend leaving at 2,000. Max number of cubes, 0. And then exposure and frame period got pulled in from the previous screen. If we want the whole image to be in one single cube, we can change the frames per cube from 2,000 to 0. 0 means infinity, so it'll just collect the whole way, so we'll do that. And then I have this use motion device checkbox, so I will check that to say we're going to use the rotary stage. And the device speed, we said 2.91, I think is what we said. And then we have a start position of -50 and a stop position of 50. I'm going to say those are fine for this. I'm going to send the system to that -50 start point. And it's going to move. We will also disconnect the LiDAR because we won't, there's nothing that we can do with the LiDAR because we're not going to get any usable data, so we'll just disconnect it, so we're not going to save that stuff. So we're at our start position, and we have our name, our exposure and frame period, and our speed set, so we're good with all that. The next thing we're going to do, similar to the airborne, is we're going to collect dark and put our lens cap on. And I'm turning off the motion device for the dark collection, so I'm going to say go. Is the lens cap on? Yes. It'll take 1,000 frames of the inside of the lens cap, and so since our exposure or frame period is at 5 milliseconds, it should take about 5 seconds. Looks like it finished. So I'm now going to take the lens cap off, please. I'm going to re-enable motion device, and now I'm ready to do my scan. So I'm at the start position, and I'm going to say go. Is the lens cap off? Yes, it is. And then I say start, or yes. And now it's going to scan from that -50 to 50, which I defined at that 2.91 scan rate. And you can see here, it is telling me the percentage, so it is at 50% now. So it should just take another couple of seconds. We can also see this captured frames increasing, so I've taken 5,200 frames, 5,400 frames. And now we are finished. So I can go back to the batch process tool, and we're going to do the FTP downloads again. Do our IP username and password, log in, And now we're going to have this NHP 110 rotary test that we just took. Again, I'm going to tell it where I want it to go. Put it in Nano images, select. And this one should be small, so I will download. And here now it says downloading data, please be patient, and it should take a minute or so. It would be a good idea to open up the image, see that it's at a good angle, if you want to adjust your start and stop times, things like that. Or if you want to move and scan a different area, you can go ahead and do that. You want to make sure that your white reference is within your field of view so that you're going to image that, and then you'll use that for your conversion to reflectance. So we did our mission with the DJI Matrice 350, but a lot of our customers also will use the DJI Matrice 300, and I just wanted to outline a couple differences between the two systems. As you can see, the UAV itself and the hardware all is the same, but the main difference is between the controllers. So here is the controller for the 350, and here's the controller for the 300. The other main difference between the two is the application which it uses for flight control. The 300 uses UGCS for DJI, whereas the 350 uses the UGCS companion app, which is a new application they've come out with. Functionally, they look similar. The only main difference is how you upload the mission. So you're going to upload the mission from the computer to the controller, but with the 350, you only have the option of starting the mission from the computer as well, whereas with the 300, you can start the mission from the controller itself. So I'm going to go through the process of uploading that mission and showing you how you do that. So I'm going to launch my Headwall GCS powered by UGCS flight control software. I'm going to make sure I say select the drone, and I'm going to choose the M300 that shows up. They're all connected via this wireless network, the TP-Link. So the computer and the controller are both on the same wireless network, and that way they can communicate back and forth. It doesn't need to have internet, just a wireless network. So I'm going to choose M300. I can open up my telemetry and control pane if I would like. This shows me battery and things like that, and then the control mode is where, if I'd like, I can start the mission from. So now I'm ready to upload to drone from route start, and now the mission is uploaded onto the controller. And once it's uploaded, there's a little button that shows up here with an upward arrow that is to start the mission. So now if I want, once I take off, I can start the mission from hitting this button or by going to auto mode, whereas for the 350, you only can start it by going to auto mode.